Welcome once again, grade 11s and grade 12s. Yes, today's topic is rational exponents and surds. Guys, the first thing that we already know is what are exponents and what are surds. Surds are all the numbers which are under the radical sign. So there is a relationship between exponents and surds. Let us try to find the relationship. First and foremost, I'm going to show you the rules pertaining rational exponents and surds. Rule number 1. It says if r to the power n is equal to a then in order to make r the subject of the formula, we must get rid of this n. How? By multiplying. In order for here to be 1, we have to multiply by the reciprocal of n, and the reciprocal of n is 1 over n. So we have to do that both sides. Now that will be r to the power n multiplied by 1 over n, and that will be 1. Good. And then here it's 1, a to the power 1 multiplied by 1 over n. Then that will be a to the power 1 over n. 1 over n. And what is the value of this? This is the same as the nth root of a. Still have your a here, and then for the radical, that is this. Now the nth root of a is still the same as this. Now we know now that a to the power 1 over n is the same as the nth root of a. Now, what is the difference between this and that? The difference is in their format, that is their notation. How do you get that? This one is in set form. Why? Because it has radical sign. This is called the radical sign. Now, this one is in the form of, it's exponential. But what kind of exponents do we have? It is not just an exponent, but we can specify it or classify it as a rational, because that is a fraction. It is exponential, that is rational exponents. Rational, it's an exponent, but which is rational. That is rational exponent. So that shows that there is a relationship between the two. Now, meaning our r is equal to 1 over that, and that leads to this, and r is also equal to the nth root of a. Now that leads to this. This implies this is equal to that, therefore a to the power 1 over n is equal to the nth root, is equal to the nth root of a. This is the conclusion. If you have something like this is the same. A to the power 1 over n is equal to the nth root of a. This is what we need to know, guys. Now let's get to the next. Now we have a rational exponent. Now a rational exponent can be positive and it can also be negative. Now let us take this. Let us take this being a negative. Suppose we have a to the power negative 1 over n. What do we know? We know that this is the same as a to the power, in brackets, a to the power negative 1. Then to the power, this is negative 1 to the power 1 over n. Now remember, this is the same as that. You see? So we are going to put for this 1/n, we are going to put a radical sign. That means this will be a to the power that negative 1 is the inverse of a. And what is the inverse of a? The inverse of a is 1 over a. This is the inverse of a. It's 1 over a. It's changed. So the exponent is still the same. The exponent is still the same. 1 over n. And what do we know from this? If the exponent is 1 over n, that is the same as the nth root of that particular base. So here we are. This is the nth, right? The nth of, what is the base? This is the base. The whole thing is the base. Then it's 1 over a. So let us just have an example where we have this. Let's say, e.g., let's say we have 2 to the power negative 1 over 4. Let's work it out first. Let's do it this way. This is 2 to the power negative 1, then to the power 1 over 4. And then this turns into 1 over 2, then to the power 1 over 4. Now this becomes this. It will be the fourth root. Now that is where we are getting to. The fourth root of 1 over 2. Now we changed it from an a rational exponent to a surd. Look at this. This is rational exponent. Rational exponent. Rational exponent. And here, what do we have? We have a surd. This is surd form. Now, meaning we can change from rational exponent to surd form, vice versa. That is what we can do. So this is the application part of this rule. Now, let's get to another rule. That is where we have a to the power m over n. Now, what happens to that? Let me continue. The first thing that we need to do is to expand this. M divided by n is the same as the factors of m multiplied by 1 over n. Then here we are. That will be a to the power m, then all raised to the power 1 over n. And mind you, let us not forget what we did in here. This becomes a surd form. Now, meaning we are going to have the nth. We are going to have the nth root. Yes, the nth root. The nth root of a to the power m. A to the power m. To the power m. So this is it. Let's make an example thereof, e.g., suppose we have 5 to the power 3 over 4. This is rational. The base is also rational. Now, how do we convert a power which is in a rational exponent to surd form? We're still going to do the same, guys. What we do is we change it like this. This is going to be 3 multiplied by 1 over 4. Now the base remains being like that. Now we change this. It's 3, then close bracket, and then 1 over 4. This symbolizes the surd form. That will be the 4th root. Now we put it like this. That will be the 4th root of 5 to the power 3. 5 to the power 3. So this is how it works. And this will be in set form, but the number which is under the radical sign is in exponential form. Now, if they say simplify that, completely simplify that, then you need to go beyond. And 5 to the power 3, that is 125. Then this will be the fourth root of, it's 25, yes, it's 125. Now this will be it, the fourth root of 125. Now this is how it works. So we are done now with how to convert from a rational exponent to sets. This is in set form. And this is also in set form. This is in set form. That is also in set form. Now, the trick is, how do we do the reverse process? Let us get to simplification of the sets. How do we simplify them? How do we simplify them? How do we simplify them? Sorry. Simplification. For simplification, we need to make it very, very simple. Suppose we have 2 or 3 sets, factors of sets. Say you have the nth root of A multiplied by the nth root of B. What is it that is common here? Is the nth root. So this will be the nth root of A multiplied by B. Now, if you have, e.g., if you have what I try to explain is, if you have the nth root of A multiplied by the nth root of B, the end product will be, because this is common, the nth root is common, so that is the same as the nth root of their products. If you have the nth root of A multiplied by the nth root of B, the answer will be the nth root of their products. So that is what is meant by this. So let us check this. Say, for an example, you have the square root of 2 multiplied by the square root of 3. The product will be, this is common, the square root. That will be 2 multiplied by 3, and that will give you the square root of 6. That is what is meant by that. So we have to apply the rules, guys. Now, this is for multiplication. What is the inverse operation of multiplication, that is division. So for division, we have the nth root of and the nth root of. We have the nth root of A divided by the nth root of B. So what do we do? The same applies. The nth root is common. So we are going to write a single nth root. And then this. The numerator is A, whereas the denominator is B. They are all under a common radical sign. How do we do this? Let's say, for an example, e.g., you had the square root of 4 divided by the square root of 64. I just want us to check this. I have two options here. Option number 1, what do you do in order to simplify this? You do it this way. That will be under the same square root. This will be 4 over 64. And then that will give you the square root of, how many 4s are in here? It's 1. How many 4s are there in 64? That will be 1. And it leaves that will be 16. Therefore, it will be the final answer. What will the final answer be? The final answer is the square root. Now we get back to this. It becomes the square root of 1 over the square root of 16, which is equal to 1 over 4. Yes, that is how you simplify that. Exactly. So, or that is option number 1. Or option number 2, you could have just done this. The square root of this. This is the shortcut, guys. I normally love shortcuts. The square root of 4 is 2. The square root of 64 is 8. And then 2 ones here, 4. And that's it. Two options. Option 1, option 2. That's it. So we are just about to finish with this. That was the third. And now let's move to the third one. Now, suppose you are given something like this. Suppose you're given something like this. Yeah. You have rule number 3, which states that is for simplification. You have the mth root of the nth root of A. Wow, I like this. Now, let us start first by manipulating it from inside. I just want to show you how you get to the answer. You work it from the inside out. This is equal to, you start first with that is the mth root of, now what is this? This is a to the power 1 over n. And then find the nth root of that, and this is equal to the a to the power 1 over n all to the power, the root is the power of mn. And what do you know? According to the laws of exponents, we know that if a power is raised to another power, what do? You just multiply the exponent. 1 by 1 is 1. This will be a to the power 1 by 1 is 1, then over mn. Wonderful. This is the inverse. So then we must write it in set form. Then it changes. Set form, this becomes m and n. mn. Here, mn. Then here you will be having a. That is a. That is a. So the final answer is, what are you going to do? Mn, that means you multiply. Say for an example, we had AG. Say we had the square root of the cube root of 27. Then what do? Start first with this. Manipulate it from inside. It will be the square root of 27 to the power 1 over 3. That's 27 to the power 1 over 3. 27 to the power 1 over 3. And then what happens to that? Then again you have the second root of this, which is the square root. So you will be having 27 to the power 1 over 3, then to the power 1 over 2. Now this 2 you multiply, that is 1 over 6. You will be having 27 to the power 1 over 6. And this should be written as the sixth root. The sixth root of 27. Now look at that. From the original, this and that. Now that means in order to get this mn, that means you multiply this by that, the roots. And then under one root, that will be the product of this and this here, and then this will be there. That exactly that. Our a in this case is 27, is going to be here, and then you multiply this 2, that will give you 6. Ashay. That's it. That's it. In short, if I want to get something like 3, then 4, root, then 6, I just write the correct answer will be, I just write this. This times this is 12, and then I put in 6. Easy. Easy peasy. This times this, the first thing that you put is this times that is 12, and then you put in this under the root sign. The 12, it will be equal to the 12th root of 6, and that is it. That's it. So it's fine, guys. So now what do we do next? what do we do next? The next thing that we do is we need to simplify. Say for an example, how do we simplify some stuff? Simplification. How do we simplify them? Number one, it's a task. It's a task. The cube root of 5 multiplied by the square root, the cube root of 4. Or 25. Let's make it 25. Of 25. Now what do we do? This will be the cube root is common, then that will be 5 multiplied by 25. And then this will be the cube root of 125, which is equal to 5. Or another option is to break this. It will be the cube root of 5 to the power 1, then multiplied by 5 to the power 2. And that gives you the cube root of 5 to the power 3. Now what happens? We remove this by 5 to the power 3. We apply that law that this becomes 1 over 3. And this time is that gives you 5 to the power 1, which is equal to, yes, that is 5 to the power 3. Yeah, this one becomes the third, yeah, it's 5 to the power 3 all to the power 1/3. Then you multiply with the 1/3 of 3 is 1. So 5 to the power 1 is 5. Now, if you look at this and that, the answers are the same. So this is how we do it. Now, another thing is we can be given a problem to solve where you have a quotient. Say for an example, you have the 25 plus square root of 3, then over the square root of 49 plus the square root of 3. In a case like this, you are going to simplify this. You're going to simplify this. The square root of this is 5, and then is 5 the square root of 3. And then here, what do you have? You have over 7 the square root of 3. And that's it, guys. The square root of 3. And then what you need to do is, after getting this, because the square root of 25 is 5, the square root of 49 is 7, then it's a plus plus root 3. So what you need to do, it's called rationalizing the denominator. Now, if you look at this, you will find that 7 plus root 3. We need to get rid of this because root 3 is irrational. Now we have to rationalize. Why do we rationalize? Because this is not rational. It's not a rational number. So how do we rationalize it? By finding its conjugate. Now, how do we get the conjugate? If you have the sum of a rational number and an irrational number. Its conjugate is the difference of a rational number and irrational number. So the conjugate, if we multiply this by 1, any number multiplied by 1 is that number. Now, meaning if we multiply this by 1, we are not going to change it. Now, I am now multiplying this by 1, which is 7 minus root 3 over 7 minus root 3. And then, what's going to happen? I just want to write it this side. That will be 5 plus root 3 over 7 plus root 3 multiplied by 7 minus root 3, 7 minus root 3. Now, you multiply the numerator by the numerator, denominator by the denominator, because this is a fraction. So, you start first. This will be 5 plus root 3 into 7 minus root 3, and then all over. This is the difference of two squares, the factors of the difference of two squares. When you multiply them, you're going to get the difference of two squares. So how do we do that? Okay, we can just let us do it like this, so that you can see exactly what I'm doing. So, FOIL method, first, outer, inner, last. 5 times this is 35. This times that is minus 3, the square root of 3. This multiplied by that is plus 7, the square root of 3. This multiplied by that is minus 3. Then all over 7 times 7 is 49. 7 times negative 7 root 3. This by that is plus 7 root 3. Now look at this. That is 0. Then this times that is minus 3. Now let us try to get rid of some stuff. 35 minus 3, that gives you 32. Now, this minus that, these are like terms. Square root of 3, square root of 3. Therefore, it's like minus 3x plus 7x. They are common, they are like terms. Then like terms can be added or subtracted from each other. So, 7 minus 3, that gives us 4 root 3. Then all over. 49 minus 3, that gives us 46. Then this, that gives us 0. Therefore, the final answer is 32 plus that, which can also be broken into this. Let me show you. Or you can write it like this. 32 over 46 plus 4 square root of 3 over 46. And then you work it out. 23, that will be 16 over 23 plus 2 here, that will be 2 the square root of 3, then over 23. That's it. Now, meaning in a simplified form, it will be 16 plus 2 root 3, 16 plus, that is 16 plus 2 root 3 over 23. That will be the final version of it. So guys, this is how we deal with that. So make sure that you know how to do this stuff. especially when you simplify sets. You must know how to rationalize. Always make sure that you use the conjugate. Conjugate, in order to get a conjugate, you change the sign between two terms. Like in 7 plus root 3, the sign is positive, then we changed it to negative. That is why we had this. This is the conjugate. We multiply by the conjugate. So there is no change done to this. This is a conjugate. 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 It's a conjugate. So I'm teaching you stuff that you're going to learn at the university, guys. Conjugate, that is terminology. Now you are now learning. Learning has no restriction. Okay, thank you, guys. Let's call it a day. And then, please, don't forget, our motivation for this week is never get into something that you cannot finish. So, and you must remember that when you finish it, you must finish it at a high note. So you started this year, that is 2020, with a high note. Now we need distinction, distinction, distinction at the end of the year. Your attitude determines your altitude. So thank you very much. Till we meet, guys. Thank you.